So we're looking at slope. While we're looking at this first picture, anyone know Snoopy, Peanuts, that kind of stuff? Okay, what's going to be the result here? First of all, what slope is Linus on there? That's not Linus, is it? Which guy is that? Someone. What's his slope there? Or maybe even if we're trying to be really interesting in terms of numbers, what's his speed going to be there? On the first one, just in that first one, yeah, 0. Right? He's not moving. Okay, and how about this one?
0.
Right. Now there's a problem there. Of course, he's running into here. If there was space, I think he'd move pretty quickly, but there's not. Okay, 0. And this one, yeah, 0. And this one, okay, 0. But you can see in this case he's going uphill. This case going downhill. This case Snoopy's having fun, and that's a flat plane next to us in that game, or 0 slope. Okay. So we'll get some of those numbers as references. Now, as we start that, let's go back and think about how we use a coordinate plane or how we measure points on a graph. If we're listing an ordered pair, do you guys remember how the order goes? Which one was first? Good guess. 50% chance. The other way, yeah. X and Y. And what does X actually mean? X and Y is true. So what does X tell us? Tells us which way horizontal. Y tells us which way vertical. Okay. So X goes first, then Y. Coordinate pairs will always go in alphabetical order. So if you end up in 3 dimensions, where you have X, Y, and then Z coming out of the paper, it'll be then X, then Y, then Z. And maybe there's 4 dimensions we can't conceptualize, then we would still have in alphabetical order. Don't worry about that till you're in your 3rd year of university calculus, so that should be fine. Okay, what direction, horizontal, vertical, does X go? Horizontal. And that leaves Y to go vertical. Okay, so with that said, let's try to reference some of these points. So first of all, A. Okay, well, this is 0, 0. This is the origin here. So the way that we find the coordinates is by kind of counting. 1, 2, 3, 4, 5. Okay, yeah, it's -5 to the left. So its X value is -5. And the way we find its Y value is counting up or down from the X-axis. So let's see. 1, 2, 3, 4, 5. Oh, and you could have just seen, of course, it's on that line 5. -5, 5 is its position. How about B? Well, I see that B is in quadrant 1, and some of you guys might remember this part. This would be quadrant 1, where it's positive, positive. This is quadrant 2, where it's -X, positive Y. This is quadrant 3, where it's -X, -Y. This is quadrant 4, where it's a positive X and a negative Y. Okay, so B is going to be positive and positive. And it looks like it's at 5 over and 2 up. Okay. Why don't you guys try to see if you can figure out what C is? And by the way, I have found generally in 20-3, labeling graphs is something people often struggle with initially. It's okay. Normal. C. So its X value is 0. It didn't move at all to the right or left. But its Y value is that it's down 1. And that one would be between quadrants 3 and 4. It's on the Y-axis. On the Y-axis, but below the X-axis. Okay, how about D? D. So that's way over to the left. Well, the X or Y should, or the X should be pretty easy. It's clearly -8 because it's right on that line. Okay, and then it's down. It's in the negatives on Y. Oh, right, -6. Okay. Okay, take a moment. Label these. Try it. Take a moment to label these. Give it a try, John. Just can I see initial thought looking at this? Who's like, yeah. It's like, no way. a different finger instead. Thank you for telling me no information. Appreciate that. Okay, pencil. Okay, so when I'm looking here, I see E is in quadrant 4. Looks like it's 1, -7. And I don't know why, but for me, it seems like quadrant 4 is the one I'm most likely to mix up. We all have things where, you sort of just sometimes switch them in your mind. For me, for some reason, when things are in quadrant 4, I sometimes end up going negative, then positive. I just notice it's down first. That's not how it is, even though it kind of looks that way. It's first of all X, then it's Y. Okay? Next one's F. That's also in quadrant 4. It's +4, -5. Brilliant. Nice. You do get extra points if you say it before the teacher. Okay, G. Let's see. Okay. -3. And what's the height? Ah, yeah. Nice. H.
0.
And
-6.
+6.
yeah, 0, 6. Good.
+6.
Last one. J. Way up here.
7, 7.
7, 7. Nice. That's my height.
7, 7. Green.
Yeah.
That would be 10.
I think Kareem was only 7'1", wasn't he? Tim Duncan 6'11". Yeah. 7'7" would be very tall. And I did already label these up here for you, the 4 quadrants. By the way, anyone know what kind of numbering system I'm writing down here? Why I'm writing these weird letters? You don't have to. You number normally. Oh yeah. You might see Roman numerals there. For some reason, that's the notation that's usually used to label a Cartesian plane, is Roman numerals. That's used for some other things. You've probably seen those before in like other classes, maybe a bit in math, but that's Roman numerals here. It uses letters. What do they call it? Geometria or something like that. In both old Greek lettering and Hebrew lettering, Arabic lettering, they would use letters and numbers kind of interchangeably. So letters would mean something different than numbers. Actually, kind of interesting example of that. You guys know about the very scary number 666 and all the stuff going with that. So that comes from like a Bible thing where it says something about you must calculate the number of the beast. His number is 666. And that's referencing in that kind of numbering thing that basically if you add up the letters of a certain leader at the time, thought to be Nero Caesar, it would add up to 666. It was kind of saying, hey, if you're looking for someone who does these things that are bad in this case, Nero is a good example. And so it was an example kind of that idea. Letters being used as numbers. Sort of interesting. Okay, now it's our turn. Now we get to graph a few of these. Graph the following coordinates. Okay, so now we get to do K, L, M, N, O, P, Q, R, S, T, no U, or V. Okay, so I'll start with a couple here. I'm going to try K. So I see that K is at X of 2, Y of -3. So some of you may like draw it out or just look for 2 on the X, 3 on the negative Y. And that's K there. Okay. That's K, okay? How about L? L, okay. It seems like the ones on the axis often causes trouble. So the axis is this line. It's not where the numbers are, it's on the line. So the point 0, 5, it's on this line, and then it's 5 up. So this point here is L. Can you guys see this okay at the back? Okay. Do you want me to zoom a bit or is it good? M, -3, +3. You might see how I kind of use my pencil to like reference the first thing, then the second thing. That's so I don't get mixed up on X and Y. And it's like, I move over, then I move up. And that's always how I do it. I move over, then up, over, then up. That's useful also when you're doing shifts and slides and that kind of stuff. Okay, this next one is 6 over, 0 up. Okay, try to do these next 6, please. That was a test, eh? Left for a minute, saw the classroom bird down, didn't. They're all wonderful. Oh, -4, -8. Does that look like about where you got it? Mm-hmm. No, Mr. Boyce, I was waiting for you to do it for me. At least a few people said yes, that's nice. P, 8-1. Q, 3, -7. Once again, for some reason, this is the one I would expect to see wrong most often. For some reason, it seems like with quadrant 4, people just either put it in quadrant 1, or they go -3 and then start working from there. I don't know why, that seems to be the one that's most often mixed up. -5, -6. That's R. S, -4, +8. And T, 6, 5. Now, a bit of a question here. If I was just asking you about distances between them, or how far apart they are, or difference, something like that, how would you say, first of all, what's the difference between point L and point T? Someone help me out with that? From point L to point T, how far apart are they? Okay, nice. They're 6 apart, or you could say from L to T is different to +6. I love that notation. Good job. So they're 6 apart. In what direction?
In X.
Oh, okay. Positive in X. Yeah, if we're just using normal person language, it's 6 to the right, right? Or it's a +6 in X. Yeah, I like that. Okay. Now, what about one that's not quite so straightforward? What about instead to go from, say, M to L? M to L. How are those? Now I know some of us would just start trying to count like it's like, oh, it's about 1, 2, 3 or something, but that's not precise. I want to be precise. Yeah, Dave?
+2 up.
Okay, 2 up. Yep. And?
1, 3. 3 to the right.
Okay, 2 up, 3 right, yeah. And would I care about order? Remember, usually X, then Y.
3 to the right, 2 up.
Okay, that's probably what you should do. Now, is it wrong to say 2 up, 3 right? No, it's not wrong. It's just, in math, there's sort of things we say that are just kind of what some random old guys in a room decided, and some things that are the way that it would have to be. Well, this is one that's, the notation is just the way that some old guys in a room decided to make it. But still, it is kind of the proper notation. We'd say horizontal first, then vertical, okay? So 2 up, 3 to the right is correct, but better is 3 right, 2 up. Okay, good. Okay, looking at this, labeling a graph. Who's like, yeah, I'm totally good at that. Okay, maybe most of the way there, but a few mistakes. Okay. I have no idea where I am, and I'm ready to drop out of high school. Good, I'm glad to see that. Please don't drop out of high school. We can get through this, guys. Very encouraged to see most of your 2 days in a row. It's a good start. Okay, so now what about if I do multiple points and make a line out of them? First of all, this might help. Okay, so I have this point at -2 and +5. There's a point. I have this point at -1 and +3. I have this point at 0, 1. Point at 1, -1. A point at 2, -3. By the way, did I really need to do 5 points to make a line? I mean, it gave me 5, so why not? But maybe I'll try to be a bit more lazy next time. Let's see, okay, I'm going to put the line through here and here. Okay, now as I'm looking at that line, anything I can say about that line? I think might describe it. First of all, is it slope? Does it have a slope? Positive, negative, steep? Not very steep. would you say there? Pretty steep, yeah. Is it going uphill or downhill? Downhill, okay. I'm going to pause, by the way, after this page to show you one of the greatest math videos of all time. Plus, then you'll understand it from the wall a little bit better. Okay, so it's negative slope, pretty steep, okay. At what point does that intersect with the y-axis? What point does that go through the y-axis? Where does it cross the vertical line? Yeah, 0, -1. Yeah, it crosses at 1. Nice. Or sorry, not -1, 0, 1. Which we had right here. Okay. That's what we call the y-intercept. Nice. We graph those midline. Now let's be a little more lazy here. Let's see what we can do here. So it starts out at -2, -2. It ends at 2, 6. Now let's just see here. If I just use this first point and this last point, I'm going to draw a line, and then I'm going to check these points and see if they match. Let's see if this works here. Boom, boom. Let's see. -1, 0. Yep, looks pretty good. 0, 2. Yep, looks pretty good. 1, 4. Yep, looks pretty good. And 2, 6. Okay, cool. Yep, nice. Positive slope. Intersects the y-axis at 2. Intersects the y-axis at -1. Nice. I'll start both of these. I want you to finish them. -2, +1. That's that first point. Okay, did that. Next one, -1, +2. Okay, that's that one. I'll let you continue. And D starts at -2, -6. Okay, got that one. -1, -3. Okay, started that one. Now I'll let you try connect the dots. Let you add the other points. See how that goes here. By the way, if some of you are saying, holy smokes, this escalated quickly, that's probably true. Okay. I'm going to pause the recording here. We will talk about a few other things, but for now I'm going to leave this here, and I will show you these in just a minute, okay? So you just finish C and D.